All right. If you think back to Friday, after we looked at your quiz um, corrections and decided if anybody's going to retake their quiz, come meet with me during advisory so that we can go over issues individually. If you don't have any, okay, and then we'll talk about a time when you can come retake it. Okay. So tomorrow during advisory, you can do that. Oh no, you have first period study hall? Oh, not anymore. Oh, okay. So then yes, during advisory. Okay. So on Friday after the quiz kind of reflection there, we did that little activity about the two ladies who are running the repair shop. If you recall, there were two ways that they were willing to pay you. Does anybody remember one of the ways they were willing to pay you, Jack? Okay, so pay an extra $100 every day. That was option number one. Option number two. Well, what were they going to pay? What was she going to pay you on the first day? 1 penny, and then she was going to do what with that? She wasn't going to add a penny. She was going to double that result every day. All right, so 1 penny turned into two, two turned into four, then into eight, so on and so forth, right? Initially, which one of those two was the better option? Oh, for real? Initially? And yeah, right. $100 today, 200 tomorrow, 300 the next day. That's way better than 1 penny, 2 pennies, 4 pennies. But in the long run, we found out that it was much better to get the penny. Yeah, because after I think it was at 28 days you were a millionaire. But after was it 18 or 19 somewhere in there that they cross paths with each other? I think. All right. Do you remember what they look like graphically? You remember? What did the 100 a day look like? Do you remember graphically? It was a what? It was a straight line, right? That one increased by the same amount every single time. It was a straight line. And the other one, it was curved. But how was it curved? Yeah, you're drawing it with your hand. Yeah, I got you. Can you put it into words? Okay. Okay. All right, so we're all saying the same thing, right? It was flat here at the beginning, right? Because it was much better to be paid on the $100 a day initially than it was to be paid off of the penny, 2 pennies, 4 pennies. But then about I don't know, it was like 10 or 12 days down, it started to grow, and by the 18th or something like that day, it got very vertical very quickly, right? And we saw that then it was going to be much better. And I think Aiden, you said by the 28th day, you're going to get $1 million or more on that day. Okay. So these two graphs are really at this point going to be the two types of functions that we know. The top one, a linear function, adding the same amount every single time. And the bottom one is the beginnings of this exponential picture that we're going to start to look at today, where our variable is now located in the power or the exponent spot. So today we're going to look at a couple of examples, and that's what we're going to use our graph paper for on the back, and then we will practice those with the stuff that's on the front. All right. So your homework is basically split into these two things. Number one, can you graph an exponential function? That's going to be the ones at the top. And she says, no, not yet, but in a minute you will be able to. And then secondly, can we identify the behavior of an exponential? Meaning, if you flip your paper over to the back or to the front there, questions 5, 6, 7, and 8. If you looked at those four right now, can you tell me which ones are exponential and which ones are not? Probably not, right? But in about 10 minutes, you should be able to tell me the difference between the two. Okay. So that's what we're going after today. Now, every exponential function has to fit that model right there. They all look like that. Y equals a times b to the x. And if you recall from Friday, and maybe you don't, right? It's the weekend, okay? We were just trying to get to that movie on Friday, right? Eat some popcorn, watch Kevin Hart, okay? That's gross, all right? Does anybody remember what went in those two sets of parentheses for the penny example? Do you remember what they were? Well, right. So in these A and B spots on Friday, do you remember what went in this first one? You're really Okay, good. It was the 1 penny. And what went in the second spot, Jack? Why was it a 2? Good. It was doubling every single day, right? So if you look at these restrictions up here, there's just a couple for these A and B spots. The first one is that A, this first value, is not allowed to be equal to 0. Obviously, if it was equal to 0, what happened to your entire problem? It'd all be 0, so that can't happen. And then number 2, what's your, in this case, that doubling thing that we had going on, it has 2 restrictions. Saying it's greater than 0 means it's going to be positive. Okay, and the second thing is it's not allowed to be equal to 1. Can you think about what happened if you took a number like 1 and you raised it to any power? What would you get? Yeah, so basically you'd go nowhere, right? It's like me saying to you, hey, I'm going to pay you a penny today, and tell you what, I'm not going to double it. I'm just going to keep it the same. That's what you'd be saying to somebody. That'd be real sweet, wouldn't it? Okay. So, couple of restrictions. So we're going to look at this graphically. How does it come about? And then secondly, how can I identify this without having to graph if I don't want to or need to? All right. So here's the first one we're going to try to graph. So we're going to put this in example number 1 on the back of your paper. Okay, y equals 3 to the x. These are different than straight lines. In a linear function, if I said to you, I'm going to graph y equals 4x plus 2, could you graph that without having to create a set of ordered pairs? Y equals 4x plus 2. Do you know where you would start? You start in the y-intercept, which was a 2, and then you would do what? Bless you, twice. Then you do your rise and your run. And in this particular case, y equals 4x plus 2. What's the slope in that equation? It's 4. So go up 4 over 1, right? So I don't need a table of values. But in an exponential function, since it's not a straight line, I can't just like plot a point and then just kind of work off of there. It doesn't have that kind of approach. So unfortunately, I have to create a table of values. And so that's why if you look at the front of your homework, questions 1, 2, 3, and 4, there's a blank table on each one of those because you're going to need a table of values. Oh joy, right? Now, it's really not that big of a deal because we're going to choose the same values for x every single time. We're going to choose the values -2, -1, 0, 1, and 2. That way, we get a little bit of the negatives, a little bit of the positives. We can kind of get an idea of what this picture is going to look like. Yeah, you can. Now, just because I have those values does not mean I know what my y values are until I plug them in. So with a calculator, I would assume 3 raised to the x. Well, 3 raised in this case to the -2nd. What is 3 raised to the -2nd? It's what? 0.1 repeated. Are you able to get that on your calculator? Okay. So 0.1 repeated, or maybe somebody has 1/9. I don't know if you turned it into a fraction or not. How about the next one? Ooh, what? 3 raised to the -1st power? 0.3 repeated? Or maybe 1/3? How about the next one? Anything raised to the 0 power? 1. Next one? Next one? Next one? Yeah, you do. What's happening every time? So it is 27. Anybody know the next one? 81. Okay. What am I doing every single time? Multiplying by 3. That's what makes it exponential. Do you hear that statement? When you multiply, not by 3, but when you multiply by the same thing every single time. All right. Okay. So when I multiply by the same amount every single time, going in this direction, it looks like I'm multiplying by 3. What about if I go that direction? If I go up the chart? So you could say you're dividing by 3. You could say you're multiplying by the reciprocal, 1/3. Like, anybody know what the next one would be up here? If I had an order pair -3, comma something, it'd be 1 over what? 1 over 27. You know what the 1 would be after that? 1 over 81. Okay. And then 1 over 243, so on and so forth. All right. So it would just follow that path. Now, as I continue to go smaller and smaller and smaller, tell me the number I'd never get to. I'm never going to get to 0. If I'm dividing by 3 or if I'm multiplying by a third, however you want to think about that, I'm cutting it into equal parts. At no point could that ever turn into 0. And if it can't turn into 0, it's surely never going to turn into what? A negative. That's not going to happen either. Okay. So for that reason, and this is why I did not put an X and a Y axis on your graph. You have to draw your own. I'm going to take my X axis. I'm going to move it all the way down here to the bottom because there's not going to be negatives. When you say get a highlighter, like get one out of your own bag or like get, sure. I don't care. Why do I care if you get a highlighter out of your bag? If you're going to say to me, give me a highlighter, then now we got a problem. Okay. So this graph is never going to cross the x-axis. Okay. At this point, I just need to graph what this looks like. Now, some of these are easy to graph, right? Like 0, 1, that's easy to graph. 1, comma 3, that's easy. How do you graph these ones up here that are decimals? Yeah, you just skip them. Like how do you graph those? Okay, good. So we're just going to estimate, right, where they should be. So -2 on the x-axis, we can do that. That's not a big deal. And then 0.1 repeated. It's like really close to what? 0, right? 0.1. So we're over here 2 units to the left because that's -2. And then we're like just above the x-axis. Okay. Then we're doing -1 and 0.3 repeated. So still close to 0, but a little bit higher than the last one. You got to watch out for them jumping calculators, man. I'm telling you right now. So just a little bit higher. But what we should start to see is what we saw on Friday. These dots should start to pick up and they should start to increase their verticality there. So 0 and 1. And then the next one is 1, comma 3. So we're over 1 and up 3. And then over 2 and up 9. Okay. Because we chose these ordered pairs to kind of help us give a picture of what this was going to look like, they are not the only pairs. So how do we indicate that? We draw the line. So to the best of your ability, we're going to kind of smooth this curve out. Now that one going up is going to get very vertical, right? You guys told me the next ordered pair after that was going to be 3 and 27, and the next one's 4 and 81. I mean, so these are like straight up in the air. But across the bottom, they're going to continue to get closer and closer to what? 0. Are they ever going to get there? Okay, so you're just going to draw your line across the bottom, like right along the x-axis. Okay, is it going to cross it? No. Should it touch it? It shouldn't. But, to the best of your ability. All right. Now, if you look at your homework for tonight, you're going to see that after we graph this, there's one more thing that's asked of you. The domain and the range. Do you remember what those are? Yeah. Good. Good. Now, somebody said that to me this morning. I can't ever remember which is which. I don't think one time in my entire life I've ever heard it phrased range and domain. Have you? No, I never. Have you ever? I've never heard it, read it. It always is domain and then range. Just like we don't say ordered pairs are Y and X, right? They're in order. Domain and range, X and Y. Like they fall in line with each other. Okay? So the domains deal with my X values. The range deal with my Y values. Okay? So just kind of try to keep those tied together. Well, so what I have to do is I'm gonna kind of define these. So like, what is my domain? For me, I chose these values, but those are not the only values that are possible. You know what they are, Jack? Now, I just literally said to you, these are the ones that I chose, but they are not all of them. Really could be anything. Mathematically, we have 3 words that describe the fact that I could have chose anything. First word starts with an A. All real numbers. Good. So, all real numbers. Okay. Or you can use this fancy symbol that looks like this. Move over here. Come on. No, you just won't move. Move over there. All right. The symbol looks like this. 2 vertical bars and an R. I don't hit the hide button, Jack, because I know that as long as this is still up, it's still recording. Sometimes it'll like just lose connectivity and cuts out. And so if I leave that there, I know that it's still working. If it's not there, that's debatable. If it's not there, I don't know if that would happen. So you're right. Hiding it would be much easier. I totally agree. But that's why I leave it up. Okay. Now, my range. Okay. First of all, I did not choose my range values. My range values came as a result of what I put in. But what's true about every range value that I got? Okay. They're never 0. That's true. In this case, they are all multiples of 3. I would agree with you. But all of these multiples of 3 look a certain way. And Kay's on the right track when she said 0 isn't one of them. And something else isn't. They're all positives. So we will say that by saying that y is greater than 0. And that would be true of every value that I get. Jack, the reason I don't say a multiple of 3 is I could give a -3 is a multiple of 3. But -3 is never going to be in this picture because I can't have a negative. Does that make sense? So were you wrong? No, but we could find some kind of like extenuating circumstances in there, so to speak. Okay. We're going to look at one more. I think that'll give us enough of an idea what's going on here. We'll check the other piece and then we'll be done. Okay. So even though you have 4 places, we're not going to use all 4 of them. All right. So here's number 2. Now here we see a value in both A and B. Part of your table you already know. What part of your table do you already know? Okay, that's never going to change. Not with an exponential. We are going to use those values every time. Ah, good. Say that louder. Say it louder. What did you just say? Does that mean what? Good. Because I'm choosing these same 5 values, even though those aren't all of the options, that 100% means that that domain will always be all real numbers. Very good. Good catch on that. All right. So I'm trying to graph this function. Now it has multiplication and it has an exponent. Which one has to happen first? Follow your order of operations. The exponent has to happen first. So you should be raising this to the power, and then you should be multiplying. What's going to happen to every one of your answers? They're all going to turn into negatives. Because the first thing I'm going to do is I'm going to take 2 raised to the negative second power. I'm going to get an answer. But then I have to multiply that answer by -1 because the exponent is higher in order than the multiplication. So 2 to the negative second power, that's 0.25. But then I multiply that by a -1, and I get negative 0.25, right? Okay. Okay, there you go. As you're getting these, what's happening with all of your answers?
Wait, I only got 0.5.
So you did that, and then you got to multiply it by -1. You multiplied it by 1.
Yeah.
Okay. What's true of every answer that you keep getting? They're negative, which means that I could come over here and I could take my x-axis and I could move it all the way up to the top because all of my answers are negative. Just move to another graph. Yeah. So I wouldn't go making my x and y axis until I know what my answers look like. All right, this next one here is -1. What's the next one after that? -2. What's the next one? -4. What's happening every time? Oh, they're going up, huh? They're going down. What's the next one? -8. Negative. Okay, there you go.
How'd you get that one?
This one?
Yeah. No, the second one.
This one?
Yeah.
Do 2 to the negative first power, and then multiply it by -1.
But the rest of them, I thought it was. Oh, I've been doing them wrong.
So like here, if you want to, so it should be 2 to the 0 power. Anything raised to the 0 power is equal to 1. Then I multiply that by -1. I get -1. So that should be that answer. So -2 to the, and then -2 paired with a -1/4 or -0.25, however you want to phrase that. The next one, -1 paired with a -0.5. What's up? Excuse me?
Like how this one, it was bottom.
Yeah, the x-axis.
Yeah.
Because when all right, so my y-axis or my y values tell me how far to go up or down. Well, every one of these numbers are negative, so they're all going to be below this line. In this one, all of my y value answers were all positive, so they all had to be above that line. So I basically just moved it down to give myself more room at the top. Here, I'm moving it up to give myself more room at the bottom. So if you're like somebody who predetermined what that was going to look like and then found out he had no room in order to do it, I mean, ooh, bad. All right. What's that? Yeah. So -1 with a -0.5, then 0 and -1, then 1 with -2, 2 with -4. Then you guys told me 1, 6, 7. The next one was going to be -8, 10, 11, 12, 13, 14, 15. And I don't know if you have room for that one on yours or not, but that would be there. Okay. So same idea. In this particular case, you are, if you're going down this chart, you're multiplying by -2. If you're going up it, you're multiplying by a -0.5 or by dividing by 2. Either way, you're never going to get to 0. So these values coming to the left are going to get really close to that x-axis but never cross it. These values coming this way, going to look something like that. Okay, to the best of your ability. It's fine. I mean, unless it looks like you're doing it on a back country road on a school bus with a pencil tied to your shoes. You know what I mean? So don't do that. Now, what about my range? Caitlin made the quick observation that the domain was going to stay the same, but I don't agree with the range. Yeah, in this particular case, good. All these values are negative, so I'd say it's going to be less than 0. Very good. All right. So you almost right now, like on your homework, could look at the first 4 questions and know that in your table of values, the X column is going to look the same every single time. I know that it's going to be -2 through +2. What I don't know is what are the Y values until I graph it. Or excuse me, until I plug in and find what their answers are. Okay. So what about something like this? Can you tell me if that is exponential without having to graph it? Quinn, you immediately went to your calculator. What are you thinking? Why do you say that?
Because
100%. I disagree with you. So you're 100% on. You said I got to multiply by something every single time. Can you find me something that you multiplied 10 by to get to 25? What? Okay. Now, if I do 10 times 2.5, I get 25. But if I do 25 times 2.5, do I get 62 and a half? Okay. If I do 62 and a half times 2.5, do I get 156 and a quarter? Okay. So if the answer is yes every single time, absolutely, that is exponential. Okay. Because it is multiplying by the same amount every single time. All right. What about this one? Is this one exponential? Quinn, what do you say? Yes again? How come? Okay. Now, I 100% agree with you. So, yes, this is exponential. However, what's up? Okay. So, technically, it has to be multiplication. Now, dividing by 2, we can turn that into multiplication. Reciprocal. What's reciprocal of 2? 1/2. So, dividing by 2 is exactly the same as multiplying by 1/2. So, is it still a yes? Yes, it is still a yes. However, technically, it has to be multiplication. All right. Say that again. Well, yeah. You had originally said to me dividing by 2, right? And I 100% agree with you that if you divide every one of these numbers by 2, you get the next one right down the line. Okay. If it was a multiple choice and you were looking for the correct answer, what I'm saying to you is you wouldn't find divided by 2. You would find though multiplication by 1/2. But they are one and the same. Okay. Yes. Yes. All right. So flip your homework over to the front. Look at questions 5, 6, 7, and 8 down there at the bottom. Find me one that is exponential. 5, 6, 7, 8. Those 4 questions at the bottom. Find me one that is exponential. By that definition, we would be looking for something that multiplies by the same number every single time. Logan, give me one. Number 6. You say yes to that reason because. So what does it multiply by? By 1/2. Perfect. So in your homework for number 6, you should say yes, multiplies by 1/2. Okay. Find me one that does not. You already got one that doesn't? Which one? Number 5. Why not? Perfect. How do you get from 9 to 12 to 15 to 18? Dang, she's such a story stamp. What is it? Addition. If you add the same amount every single time, what do you actually get? You don't get an exponential picture. If you add the same amount every single time, you get linear. You get a straight line, right? Just like on Friday, adding $100 to your total every day gave you a straight line. It did not give you the exponential picture. All right. So that there was 8 questions on your homework. We just did 2 of the 8. right? We know that all four graphs at the top have to have the same domain, -2, -1, 0, 1, and 2, because that's what we're going to choose. We just need to find the corresponding y values to go with it.